In this video, we'll talk about L'Hopital's rule. First, let's look at these two limits. So on the left one, if you plug in x equal to 1 into this rational expression, you will get, on top you will get 0. At the bottom is also 0. And we have the situation of 0 over 0. And this is an indeterminate form. Another indeterminate form is infinity over infinity. Well, if you look at the second limit, on top, as x approaches infinity, the top approaches infinity, and the bottom also approaches infinity. And we have the form infinity over infinity, and this is also an indeterminate form. When we see an indeterminate form when finding a limit, we can use L'Hopital's rule, which is taking the derivative of the numerator and the denominator. So for example, for the first limit, we have the indeterminate form 0 over 0. So here we can take the derivative of the top, which will give us 3x squared plus 2. And the bottom, the denominator, if you take the first derivative, you have 2x. All right, and now let's plug in 1 into this expression. You have 3 times 1 squared plus 2 over 2 times 1, which is 5 over 2. That will be the result for this limit. Similarly, we can also apply the L'Hopital's rule when finding the limit for the second example. Since it's the indeterminate form, infinity over infinity, we can take the first derivative of the top, which you will get 2 times e to the 2x, and take the derivative of the bottom, which is 3. Okay, now let's plug in infinity into this expression again. So on top you have 2 times, well, 2 times x is 2 times infinity is also infinity. So e to the infinity goes to infinity, and you multiply by 2, it still goes to infinity. So the top goes to infinity, the bottom is 3. So pretty much you get infinity over 3, which is infinity. So the limit for this expression is infinity. Another 3 indeterminate forms that can be solved using L'Hopital's rule is 0 to 0, 1 to the power of infinity, and infinity to the power of 0. If you're trying to find a limit that is in one of these 3 indeterminate forms, we can also use L'Hopital's rule. Let's take a look at this problem. Okay, if you plug in 0 in this expression, you have basically 1 plus 0, 1 to the power of infinity, right? So it is in the indefinite forms, one of the indefinite forms. Here we will make y equal to this expression, 1 plus 2x to the power of 1 over x. Okay, and here we'll take logarithm on both sides. We'll take the natural log on both sides. So on the left side we'll have ln of y equals, on the right side is ln of 1 plus 2x to the power of 1 over x. So according to the power rule of logarithm, you can move this power to the front, right? So you have 1 over x times ln of 1 plus 2x. Well, if we move x to the denominator, we have ln of 1 plus 2x over x. So if you take the limit here, as x approaches 0 on both sides. Okay, so on top here we have ln of 1 over 0. And we know ln of 1 is 0, so here we're in the indeterminate form of 0 over 0 again. Here we can use the L'Hopital's rule. Okay, so on top, we will have, taking the derivative of the top, you have 1 over 1 plus 2x times the derivative of 1 plus 2x, which is 2, over the bottom, take the derivative of the bottom, that is 1. Okay, now let's plug in 0 into x again. You will have 1, basically 2 on top, 2 over 1 plus 0 over 1, right? Which basically is 2. So this means the limit of ln of y is equal to 2. As x approaches 0. Okay, so ln of y equals 2, that means y equals e to the second power, right? Of course, here we're still taking the limit as x approaches 0. All right, so we know we're looking for the limit of 1 plus 2x to the power of 1 over x. That is y. So basically, that is the answer to this limit. Replace y with 1 plus 2x to the power of 1 over x. That is e to the second power, e squared. Okay, here let's look at another example. All right, we want to find the limit of 1 minus 4 over x to the power of x as x approaches infinity. So let's plug in infinity into this expression. We'll have 1 minus 4 over infinity, which is 0 here, right, to the power of infinity. So we have the case of 1 to the infinity again. So here, this is an indeterminate form. We will use the L'Hopital's rule to solve it. So first, let's make y equals 1 minus 4 over x to the power of x, because we want to take the natural log on both sides so that we can move the x to the front. So you have x times ln of 1 minus 4 over x. All right, so here, I'll make the x to the denominator by changing it to 1 over x. All right, so here on top, you will have, x approaches infinity. On top, you have ln of 1 minus 4 over infinity, which is ln of 1, right, which is 0. That's the top. The bottom is 1 over infinity, which is 0. So you have the case of 0 over 0, which is the indefinite form, indeterminate form. So we can use the L'Hopital's rule, right? So taking the limit here as x approaches infinity, so meaning taking the limit here, we can use the L'Hopital's rule to take the first derivative of the top. You have 1 over 1 minus 4 over x times the derivative of 1 minus 4 over x. So that is negative 4 times negative 1, right, times x to the negative 2. Now, over, take the derivative of the bottom, you will have negative x to the power of negative 2. All right, let's simplify this a little bit. We both have, x to the negative 2. We can cancel that out. So this is a positive 4. So you have, then you have a negative sign here. So negative 4 over 1 minus 4 over x. Don't forget we're taking the limit here as x approaches infinity. The limit as x approaches infinity. So if you plug in infinity to replace x, you will have negative 4 over 1 minus 4 over infinity, which is pretty much as 0, so that's a negative 4. So what does it tell us? This tells us the limit of ln of y is equal to negative 4, but we're looking for the limit as x approaches infinity of y, right? So if ln of 4 is negative 4, then y equals e to the negative 4, and that will be the answer because the limit of y is the limit of what we're looking for.